Okay, so this is 9.1 again. Okay, so 9.1. And 9.1 is about, it's called, the major chapter is called Simplifying or Working with Radicals, something like that. There's just a lot in this section. Okay, so a quick reminder. This is from video number 2. It would be very helpful if you practice the questions for video number 2 before you listen to this lesson. So if you haven't done your homework, you should do your homework related to 9.1 video 2 first, which is called Rationalizing the Denominators. So this should be a reminder. So let's look at this again. So how did we do this? Now, if this doesn't feel like a reminder to do, you want to go back and watch video number 2. Okay, so one choice we had, remember we didn't want the square root in the denominator? There were 2 choices. One is you could multiply the top and the bottom by the square root of 12. But I have an equal to sign first, so I'm thinking that's not what I want to do. What I want to do first is I want to simplify this number. Okay, so I want to make a tree. So I'm not supposed to have a radical in the denominator, but if I make a tree, maybe that'll save the whole thing, but probably not. So 4 times 3, 2, 2, 3. So the 2 comes out. Remember the twins? So 2 comes out, 3 stays in, and there's a 3 up here. So remember, we don't want the radical sign in the denominator. So how did we get rid of it when it looked like this? So when it looked like this, if we multiplied by a matching radical, now just the radical, not the 2. Although the 2 would work, it would be more work for you. You multiply by the matching radical in the denominator, the top and the bottom. Just like from our last assignment, there's a 1 in the front here. Outside times outside. Inside times inside. So if you have 1 out and 1 in, you have to keep them separate. That's also what I did in the denominator, actually. There's a 1 here. So when I multiplied, I got 2. Whoops. Didn't mean to delete that. Okay, now we got to keep going. So the radical 9, think of what radical 9 is. That's 3 times 3. So it's a plain 3. So you don't want to keep the radical. You now freed the 3's, the twin 3's, from the radical. 3 radical 3. So this is 3 radical 3 divided by 6. Now normally that would be the end, but we got an outside outside, and both of those outsides have a common factor. So what would I divide this one by? What would I divide this one by to get the final answer? So divide this one by 3, divide this one by 3, and we get 1 radical 3 over 2. This would be the answer. Or, if you want to, you don't have to put the 1 in the front. But either way is fine. You get full credit for both. So that was a reminder. So, if you have this 3 over 2 radical 3, you would multiply by the radical of the denominator, and you multiply that on the top and the bottom. So, we have a new type of problem that we're going to be working on today. It kind of looks like this one. So, kind of looks like. But there's a slight change. This one, there's a plus in the middle, or a minus. So they're not attached. Okay, so this is our first example for today. So we're going to write this. There is a plus or minus, subtraction, addition or subtraction, in the denominator. So over here to the side, we're going to write investigate. So let's see what happens if we tried to do the same thing that we did in the problem above. So the problem above's right there. What did we do? We said we don't like the radical here. So we said we could multiply by radical 3, radical 3. The only issue with this one comes is this radical 3 has to multiply by both things in this radical, in the denominator, sorry, in the denominator. So your numerator is 3 radical 3, but the denominator is the problem. So let's see. So 2 times radical 3 is 2 radical 3, plus radical 3 times radical 3 is radical 9. Well, we did free the 9, it's 3. But it's like I moved the radical. So at first, the radical was at the end, in blue here. Now, it's in the front. But it's still on the bottom. Still on the bottom. So that's not helpful. So this is trial number 1. That was a no. Trial number 2. How about if we just multiplied the exact same thing on the bottom? Like the same. So maybe we could multiply by 2 plus radical 3 on the top and the bottom. Now the bottom is our biggest concern. So let's work out the bottom first. The top's pretty friendly to do. But let's focus on the bottom. Now this looks like what you were doing yesterday. So you were multiplying the 2 times the 2, distributing, remember? And then 2 times the positive rad 3. Positive rad 3 times 2. Positive rad 3 times 3. Seems like a lot of work, but let's see. If it works, that's our whole plan. It doesn't matter how much work it is. So 2 times 2 is 4. Hey, that's good. That doesn't have a radical. 2 times radical 3 is 2 radical 3. Plus 2 radical 3. Plus radical 9. I'm going to put a little note over here that says radical 9. But what is radical 9? It's 3. So that looks pretty good, except here I get 4 radical 3. I'm going to write that in another color. So this is 4 radical 3. But I didn't want any radicals. So how am I going to make this happen? Now there's 2 radicals. They match. But how could I get rid of one of them? So I don't want them both to be positive because that gave me 4. But what if there was a way that made this positive sign a minus? Then I would get 0 radical 3, which means there's nothing in the middle. So is there any way for me to get a minus right there? Or a minus right here? Now, I don't want them both to be minus, but if I had one of them minus and not the other one, that kind of feels like a dose, a difference of squares. So back up to this 2, our trial number 2 is almost. How could I change it? Well, right now, both of the signs here are plus. So I'm going to get pluses in both locations. Maybe if I made one of them a minus, then it would work. So let's see. So this one's going to work. So let's put a little star. So this one, let's put this one. So this is trial number 1. Trial number 1, it did not work. Trial number 2, almost worked. Trial number 3, let's get this one to work. So let's see. So we have 3 over 2 plus radical 5. So that's the beginning again. And when I multiply, what if I change the sign in the middle? What if I change the sign in the middle? let's see. Now, the 2 times the 2 is 4. 2 times negative radical 3 is negative 2 radical 3. Positive radical 3 times 2 is positive 2 radical 3. Those are going to cancel out. And then this is radical 9, which I know. So this one's going to work. So let's actually work this one out. So let's distribute and let's see. So 3 times 2, 6. They're both outside. 3 times negative radical 3 is negative 3 radical 3. And then let's try the denominators. So for the denominators, you have to multiply them out. So you're going to multiply 2 times 2. I think my green line was a little too far. So 2 times 2, this one, that's a 4. And then 2 times radical 3, negative radical 3, is negative 2 radical 3. Positive radical 3 times 2 is positive 2 radical 3. Positive radical 3 times negative radical 3 is negative radical 9. So these two middle ones are opposite. Now they're opposite, but they're the same. Same numbers, opposite signs. When you add them, you get 0. Which is exciting because that was our whole goal. We don't want any radicals in the denominator. So 6 minus 3 radical 3 divided by the 4 is still a 4. But this one is a minus, a radical 9. So radical 9 is 3 times 3, so 3. Oh, this one's kind of interesting. Turns out that you get a 1 in the denominator. That's rare. So this is the answer, or you know that 1's in the denominator don't really need to be there. So that's the final answer. So this is the way. So let's go back up to the top. If I'm going too fast, you can always pause. And if the screen's not very clear, hopefully it's not too late for this, but if the screen's not very clear, these are being recorded in high definition. It's just that you have to change your YouTube setting to be high definition in order to see the letters more clearly. So I'll post that in Google Classroom so that you know. Okay, so let's see. Let's write that one after all this investigate over here. Okay, all this investigate stuff that we wrote here over the side. Okay, so we decided it was this one, but it kind of looks like a big old mess. So let's write it over here. So 3 over 2 plus rad 3. What you're going to multiply by is 2 minus rad 3. 2 minus rad 3. So this actually has a name. The one that has the same numbers, but the sign in the middle is different, is called the conjugate. Conjugate. So that's what it's called in math. So the only thing that's different is the sign in the middle. That's called the conjugate. And then let's see. So let's distribute those. We get 6 minus 3 radical 3. Yes, it's the same thing as we did in trial number 3, but if it's here, it's going to make a lot more sense. Investigate usually means that you don't have to look at it, right? So you really just look at the examples. But it's nice to know where it came from, especially if on the test you make an error and you're like, how come it didn't cancel? And then maybe you'll think, oh, I have to make them opposite. Okay, so 2 times 2 is 4. 2 times negative radical 3 is negative 2 radical 3. Positive radical 3 times 2 is plus 2 radical 3. Positive radical 3 times negative radical 3 is negative radical 9. 6 minus 3 radical 3, that's the numerator. And the denominator, those cancel like we wanted them to. 4 minus, you work out the 9, which is 3. And then the denominator is 1, and the top looks like this. And then you don't need the 1 on the bottom, so you can write it like this if you want. It's very cool. So that is also called rationalizing the denominator, but there's a plus in the middle instead of a times. So let's go back up and look at this again. Might need to pause so you could finish writing if I'm writing too fast. Okay, but if you go back up here, notice in the one up here, there's nothing here between the 2 and the rad 3. This one down here, the blue plus, is a plus sign. So this is still called rationalizing the denominator. So I called it simplifying radicals, but specifically both of these topics is still called rationalizing the denominator. Okay, and that's because we want no radical in the denominator. We'll see. My battery is running out. We'll see if I make it through this video. Okay. I have 1, 2. Well, it says there's 4 examples, but I don't know. I'm missing one. That's okay. I'm using an old student's notes, whatever I taught before, so I don't have to make up problems as I go along. So I guess technically, we did this first one could have been called example 1, which was the reminder. And then this would be example 2. And that's how we got 4 examples. So this would be example 3. But example 1 is a different type. So it doesn't look like today's work. I don't usually number my examples. So if my student numbered the examples, that was the only reason why. So let's see. Let's see a new one. So radical 5 at the top. And in the denominator, we're going to have 3 minus radical 7. Now, you have to notice that this is a minus. So that's a minus, so you cannot multiply by radical 7. Because if I did multiply by radical 7, this one makes a nice one. That one makes a rational number, but that one gets me a radical again. So that's not a good plan. But if you tried it, you would notice, okay, that didn't work. Remember, your aim is no radicals in the denominator. So you are going to multiply top and bottom by the same thing. You still don't want this radical in the denominator. But what you're going to do is what we found in our trials is that if you multiply by the identical thing, but instead the opposite sign, it makes it cancel. And remember, this was called the conjugate. It's called multiplying by the conjugate. Now, whatever you put in the denominator, you have to put in the numerator when you multiply, because you're really multiplying by 1. You're going to learn a lot more about that in chemistry. It's called conversion factors. So you're allowed to multiply by 1 to make things different. Okay, so you distribute. Radical 5 times 3 is not radical 15 because the 3 is outside. The radical 5 is inside. So that's 3 radical 5 plus radical 5, radical 7. Are those both inside? Can I get radical 35 or not? And the answer is yes, I can. Because radicals, when you're multiplying, you don't have to have a like radical. This one you do have to multiply out like we used to do. So this is 3 times 3, which is 9. 3 times positive rad 7, positive 3 rad 7. And here's where what we picked is going to work, because that's minus 3 rad 7. So that's going to get the rad 7s to cancel. And then minus times plus is minus. Rad 7, when you multiply it, you get rad 49. Numerator, let's see. Tree, 7 and 5. Anybody come out? Nope. So 3 rad 5 plus radical 35. And I'm really going numerator to numerator, and then I'm doing denominator to denominator. So when you're following the work, sometimes it looks funny. It's hard to know what you're looking at, but you have to just be very careful. You can also work sideways, but usually if you work down in math, people get more right answers. Okay, so that's still a 9. In the denominator, I'm looking at this denominator right here. So see how you can simplify that denominator. So the positive 3 radical 7 and the negative 3 radical 7 do cancel. But if they were the same sign, they wouldn't cancel, and then it wouldn't work. Minus radical 49 is plain 7. And that's the whole point. I want nothing there at the bottom. The book does it in some funny way with a formula, but I don't know why we would need a formula when we already know how to distribute. So how are we going to remember the formula when one day you need it in math analysis or college algebra or calculus, and then you're like, what was that formula again? You're not going to remember. Now you have to remember certain things like quadratic formula. Actually, this one kind of looks like the answer to a quadratic formula problem, doesn't it? So maybe we should hard simplify. The numbers in the front of the radicals. Well, that's a 1. So 1, 3, and 2, do they have a common factor? Nope. So that's the answer. So you don't really need the hard. But remember, hard simplifying was things that were outside. You can simplify them as long as there's the numbers in common. That's positive. Check from my step above. Yeah, so that's this. So this one's the numerator, this one's the denominator, if you're having trouble following my work. Okay, so our last example for this video, example 4. Hey, the videos are all about 20 minutes. It's interesting. Okay, so multiply by the conjugate, 6 radical 3, so this one's a little long. Last one was a little short. Radical 7 minus radical 3. I still see the minus. Now, it can be a minus or a plus. So a minus or a plus, I look at it and I say, well, wait a minute, how am I going to do this? So if you forgot, you could try to multiply by radical 3, but it would turn out not to help. If you multiply by radical 7, it doesn't help. But if you multiply by this item called the conjugate, and you'll see that word a lot in math, in upper levels math, conjugate, instead of a minus, you're going to put a plus. So you're going to put the other sign. And that's so I can get those middle terms to cancel. It's like the partner in a difference of squares. Same exact thing, but opposite signs. And this is your plan, so you have to pick that red. So it doesn't tell you. You're going to have to pick it. So which multiplies? The 7 times the 3 or the 7 times the 6? So it's the 7 times the 3 because they're both inside. 6 radical 9. Oh, we'll have to work that out later. Radical 7 times 7 is radical 49. Radical 7 times radical 3, positive radical 21. Ooh, and here's our negative radical 21, so our plan's going to work. Minus radical 9. Okay, we can work out the top. Maybe I'll work it out sideways. So 6 radical 21. Oh, 21. Tree, 7, 3. No one comes out. Plus, oh, the 9. You know 9. 9 is 3 times 3. So it comes out, which means there's nothing left inside. It's just plain 3. I've been writing plain so that you don't accidentally keep your square root. Square root of 49. Square root of 49. Negative square root of 9. Square root of 49 is 7. Minus square root of 9 is 3. And you get 6 radical 21 plus 18 over 4. And here we go with our heart simplifying. So let's see. Our heart simplifying. Well, that's not really, there's no radical over there. So that is what's in the front. So all 3 of these are outside. Kind of looks like a heart, like in quadratic formula. So do you know a number that goes into all of them? 2. Make sure you put your divided by after the numbers. Doesn't make sense if you put it before the number. Like if you put this, that doesn't make sense in math. So please don't write it in the front. Okay. Anyway, back to this. That is 3 radical 21 plus 9 over 2. That's your answer. The end. So we're also going to do one more part. It's a little complicated. It's pretty complicated. So video 5 or video 6 actually. This is video 4. So maybe we'll just have one more video. But it's a tricky one. We'll see. We'll see. Okay. Anyway, this is called multiplying by the conjugate. Okay, so multiplying by the conjugate. And it's also called rationalizing the denominator. But there's 2 types of problem where you rationalize the denominator. One is you just have 5 over radical 7. No plus or minus. Those are nicer. Or if you have a 2, but there's no plus or minus, multiply top by radical 7, bottom by radical 7. That's it. It's very friendly. And these aren't too bad either. Makes you do a lot of math, but it's really makes sure you know what you're doing. You can add like radicals. Do you know what the square roots are? Do you know your outside times outside rule? So it's very nice. You'll learn all of it together. But you got to practice it or you won't remember it. So make sure you practice too.